When we're working with quantities in physics, we have to consider a couple different things, and one of those is what type of quantity is it? And two of the types that we're going to talk about is a vector quantity and a scalar quantity. And it's important to know the difference because it's going to help you understand the situation conceptually, and it's also going to help you do the math. So scalars are physical quantities that only have a magnitude. The direction of it doesn't matter. So it's just how big it is, what size it is, but not what direction it's heading. So for a plus or minus indicator on a number would only tell you where it fits on a number line or a scale. So that an example of that would be temperature. It's cold outside, it's minus 10 degrees. Doesn't tell you that it's backwards 10 degrees, it just says it's below zero. So that's a scalar quantity. Mass is a scalar quantity, time is a scalar quantity. These are things that it really direction doesn't make sense for. The quantities that direction is important in are called vectors. And vectors have both magnitude and direction, so it's going to have a size and a direction that's going to relate to the motion. There's a lot of different ways to represent the direction, plus or minus, north, south, east, west, up, down, left, right, or even angles when we're talking about circular motion. When you draw vectors, you want to use drawings to help you solve your problems. You're going to use some sort of proportionality for your arrows to show one thing bigger than the other, draw them in the correct direction, things like that. And so one example of a vector is the acceleration due to gravity, which is objects falling downward. It's negative 9.8 meters per second squared, or 9.8 meters per second squared down. Here's a list, vectors and scalars. So there's a couple that are similar, but the calculations are different and their meanings are different. So the vector for position is going to be displacement, and its scalar is distance. The vector for how fast you're moving is velocity, and its equivalent scalar is speed, but they're not the same thing. We do tend to use them interchangeably, but be careful. Acceleration is a vector, weight is a vector, and force is a vector. Time, mass, energy, and temperature are all scalars. And the big difference is direction matters or not. So when you're drawing vectors, I talked about how you need to draw diagrams to solve the problems. When you're drawing the vectors, they're drawn as an arrow. And you draw them tip to tail if you're using more than one vector. When you're working in one dimension, you kind of offset one. Two-dimensional, you'll have angles to work with, and just try to represent them as best you can. So the direction is indicated by the arrow point, and the length of the arrow kind of gives you the magnitude of the vector. Quick and easy problem, adding vectors if it's all in one direction, either horizontally or vertically. It's an addition problem. So you've got positive 10 kilometers displacement, and then turn around and go back 3 kilometers, and your total displacement, or the vector addition of this, is going to be 7 kilometers. And notice it's in the positive direction. It gets a little more complicated when we're talking about angles and we start heading off in different directions. We all don't go in just one direction all the time. We've got to talk about some of the vocabulary with this. When you're adding these vectors and the ones in front of it, you're going to get a resultant. So the resultant is the sum of any vectors, whether it's 2 or 3 or 200, the resultant. And then all of those pieces that make up that vector are called the components. Resultant has a magnitude, and in this case that we've got here, it's a length, and it's going to have a direction, and we are actually going to go through and find an angle for it, not just say, oh yeah, it's headed off in the northeast. Sometimes that's good enough. A lot of times you need to have the angle to be perfectly correct. So when we're adding these, notice it's a right triangle, so you can use Pythagorean theorem. And you end up with the resultant being 10.4 kilometers. Then we need some trigonometry to find the angle. And our final resultant ends up being 10.4 kilometers, 16.7 degrees north of east. That is the whole correct answer. You need all of it. You need the magnitude, you need the units, and you need the direction. And then the final piece to this is, what if you start with that vector resultant and you have to find the pieces of it, which we'll be using for some of the problems down the road. And so here's a quick example. We have a rope tied to a wagon. It's got a 30-degree angle with horizontal, and we're pulling a cart across the floor. We're applying a force of 20 newtons. And the physics part really doesn't matter right now, so don't panic. We're just focusing on the math. So I'm asking you, what are the horizontal and vertical components of that vector, that 20 Newton vector at 30 degrees? So we're back to trig. We can't use Pythagorean theorem because we're trying to find the components, but we can use trig. And so remind yourself what the definitions for sine and cosine are, and then you just plug things in. To find the force in the x direction, which is the horizontal force, we have the adjacent side over the hypotenuse. And so cosine of 30 is equal to f of x over 20 newtons. You work through the math, and you get fx is 17.3 newtons. You do a similar thing using the sine, and you end up with the force in the y direction, or the y component, is 10 newtons. So that's how you work with vectors. You'll get more practice later on. Bye-bye.